Hello, and welcome back to the Message from Deep Space. This is episode 20. I'm Alex Rose, aka Safety Net, and last time we got to learn a whole bunch of alien units. So we can do alien science, like this. So, the aliens want, within 3 sig figs, the volume of the meteor, which we can do pretty reasonably. So we are going to use the setup that they gave us, because that feels like it would make for the most likely to be accurate. So we're going to do 10.6, 2.1, and 12.7. 10.6, 2.1, and what was the last one that I said? I don't remember. 12.7. 12.7. And round that up. No signal change. Oh, we probably need to include units. So we are, well, hold on. This says alien meter 3, so I'm assuming that this is alien meters cubed. Just to be sure that I don't want 282. Well, how would we define volume? So I would say 30 cubic feet, 282 cubic feet. Let's see. Are they noticing that I'm doing something wrong with the formatting? I see in the reference tab that the meteorite has a volume, 4,053 cubic meters. How do we convert that to cubic alien meters? I have 1 cubic meter of water. There are 100 centimeters in a meter. How many cubic centimeters of water do I have? 1 times 100, so 100 cubic centimeters, I assume. Though that doesn't seem right. Not right. We have 3 dimensions to deal with. So we multiply by 100 3 times. Oh my, 1 cubic meter is 100 times 100 times 100 cubic centimeters of water. That's 1,000,000 cubic centimeters. Correct. Each alien meter is roughly 1.80236 human meters. So let's divide by that 1.80236 3 times to run to calculate a proper response. Okay. I feel like my method should have worked too, but I'm gonna guess that they calculated a volume that was not just a prismatic volume and was in fact something different. So we are looking at a volume of 4,053 meters cubed. So 4,053. And what was that area that Dr. Bautista had calculated out? $1.80236. Okay. So that was one. Shoot. Well, shoot. I've gone and pasted the wrong thing. Okay, let's try that again. 1, 2, 3, 692. It's much bigger than I was calculating. Why was mine wrong? Not to worry about that, I guess. Okay, meteorite 0 mass. Meteorite's mass rounded to 5 sig figs equals 871,000 Altons. Now, that doesn't seem right, because this was measuring an atomic mass, right? Well, I guess the Alton was measuring... No, yeah, that doesn't seem right. So it's probably not as small as a Dalton. It's probably more like a gram. Woo! Transmission 300, can you believe it? Yes, we work every day for 12 hours. It only makes sense we would progress so far. That party pooper. But I see his point. Oh, come on, Carrie, let's celebrate. It's the big 300. I think he is celebrating in his own, albeit strange way. You're celebrating our hard work and dedication, right, Batista? Oh, sure. Never mind. Party pooper Batista. Okay, so meteorite moves some speed. I think this transmission is an info dump. They're giving us the specs on the meteorite. Yeah. I've thought a lot about these past few weeks. I'm happy to be here, to be part of the team. Thanks for helping me understand my place in all this. I'm happy to be part of the team. We're happy to have you, Alan. Though it was quite vain. Batista. No, there's some truth to that. More than I'd like. But I'm in much higher spirits now. It's quite obvious, and I'm happy to see it. Though I could use some coffee. So if you could run for too soon, you... Acres! You are lucky the transcript didn't catch that. I love my team. Okay, so... The meteorite moves at a speed equal to var0. var0 is greater than 446,000 alien meters per second and lower than 558,000 alien meters per second. So because the alien meter is roughly twice as long as the human meter, that means that it's going between like 900,000 and 1.1 million meters per second, which puts you in the range of about 0.5% of the speed of light. It's pretty dang fast. Okay, I'm going to change the dictionary definition from the Alton. No, I'm going to keep it. So we do already have the hologram here. Okay. So, got 2 new words. Exciting. I thought we were already up to negative 75. 70, 71, 72. No comment on this making a happy dictionary? Okay, so we're learning 2 new concepts at once. Unknown A is a time unit. Unknown B is a time unit. 1 unknown A equals 3,528,238 seconds. So I'm going to say this is their day. This is the alien day. And this is the alien year. So 1 second is less than 1 something, which is less than 1 all day. Wait a minute. Wait a minute. This is not. This is 3 billion seconds. So 3 billion seconds in days, I believe, is close to. It's a lot of days. Wait, no, this is 3 million seconds. So 3 million seconds in days is probably closer to the month. And this is close. This is still about the year. Is it? No. 10 million. So 1 second is less than 1 something else, which is less than 1 all day. Now, I have speed defined, and I have second defined, but do we have a middle unit here? Because, okay, yes we do. So this is the, it's all semantics, but I want to get something that feels right. So this is the all week is less than the all day is greater than 1 second. Aliens make Meteorite Zero. Aliens originate Meteorite Zero and move to humans' destination. Meteorite move humans' destination time equal many seconds. Equals $70. I'm not even gonna try. Okay, I'm gonna try. 1,000 million billion 7 trillion seconds. That is an unfathomable amount of time. That is 30,000 years. Right? 1. So this is 1,000 million billion trillion. 7 trillion seconds. It's not even 1,000 years, or it's not even 30,000 years. It's 7 times that. Well, more like 6 times that because of the alien second. Which means that it took 180,000 years for it to get here. Holy moly. I don't. That's a lot. Okay, well, let's find the ratio. 3528238. Oh, we have an alien units reference tab. And okay. I am seeing that I had my scales a little wrong here. Which is that the Alton is not a microscopic measurement. It is the mass of a clump of iron. So thank you. What do I name this then? Guess we'll call it the all planet mass, and we'll change this to the algorithm. Out of curiosity, what do they suggest for the names for things like the algorithm? Acre pound, alien gram, minor mass. And what about the all planet? The mega acre pound, the alien Ronogram, the major mass. I do like major mass. Okay. Right. So we've got a unit that is 3528238 divided by 1006893. Okay. Whew. Now it seems like they're mostly moving in whole numbers here. So we're going to take 1989715. One nine 89715, and we are going to multiply this by 3.50408. And we will follow suit. Nope. I guess we will leave it at 0. Nope. Okay. Oh no, this is a pass-through. They're not asking us to convert. Silly me. Okay, aliens originate meteorite and move to human destination. Distance equals distance 0. Distance equals speed time multiplied. Yes. Meteorite speed is greater than 2,353 alien light seconds. Alien light second all month. Oh. And meteorite speed is less than 2941 alien light seconds per month. Meteorite time equals 1,900 equals 1,989,715 all months. Therefore, distance 0 is greater than var 0, and distance 0 is less than var 1. Okay. So, we're going to take this is if we take the alien light second and we multiply it by the all month, then that gets our lower bound and our upper bound. So shove that into a calculator. Multiply that first by 2353. Shove that back in. And then multiply that by the all month, which is a pretty big number. Which is 1,000. Okay, yeah, they gave us the number. Thank you, aliens. 19,89715. And you know what? We should probably multiply by the alien light. That by the alien light second. Okay, wait. I gotta make sure I actually do this right. So we're moving at a speed of 2,941 alien light seconds per all month. We know how many all months we traveled. So we take this all month number and we multiply by this number, and that gives us the alien light seconds minimum. Okay. So we don't need to grab the alien light seconds. 2941. Okay. And then the upper bound, that was the upper bound. 2353 is the lower bound. So they are much farther than anticipated. One nine eight seven one five 2353. No, this is the amount of all months that they traveled. Okay. So we have, if this is the amount of all months that they traveled, we need to convert this to seconds, which we can do by multiplying by the all month value. Okay, it got even farther. It was already far and it got much farther. Wow. Oh, wow. Um, so we're gonna take 2941. You're gonna multiply by the alien all month. And then we are going to multiply again by the amount of all seconds in the all month to convert to the alien light seconds. That's long. That's too long. That doesn't make sense. Yeah, that's way too long. Okay, so let's define an equation. If you are moving 60 miles per hour, and I asked you how many miles did you move? How many? Yeah. And you had the term minutes, and you needed to convert to hours. Is that what's going on here? So our month. Hold on. How do we set up the canceled units here? Um, um, let's see. What was our alien month again? Okay. But they gave us this conversion here. So they are telling us that the all month is equivalent to this many seconds, which is many. It's a lot of seconds. 7020187650953. Okay. And it wants us to type out the whole number? Like the whole thing? Okay. I guess you traveled this far. It's the least I can do. 2353. Multiplied by this number. I plugged it into Desmos off screen, so it was easier to move. And 2941. It's very, very far. No signal change. I could have sworn I was doing it right, though. Why would you give it to us in the previous transmission if that's not correct? Is that not the amount of almonds that we have? Yes, it is. It takes this many seconds. And the distance is greater than var 0, and the distance is less than var 1. And these define our lower and upper bounds. I guess we could include the unit of alien light sec, but that feels kind of needy. Okay. So let's reevaluate. If they had been moving at, it took them 1,989,715 all months, and they were traveling at this many alien light seconds per all month. So the all months actually cancel each other out. So we just need to know how many all months we were traveling, which we do, because it was 1,989,715. And because those cancel out, we can just do the smaller unit. And so we probably had the right answer first, but missed it because we didn't include our distance unit. Okay. I think that makes more sense. Still very far, still very long, but like we were talking about like billions of light years away. Okay, alien human distance is greater than that many light seconds, the lower bound that we put. And aliens and humans distance is less than the upper bound. Yes, we know this. I double-checked the math. 1,989,715 all months converted into human years is 179,442. Wait, that must mean the aliens sent the meteorite 180,000 years ago? Oh, how many generations have they waited? More than like all of recorded history. Okay. Okay, so statement 0 equals statement 1 or statement 2. Statement 0 equals true. Therefore, statement 1 equals true. This seems like it should be another or. Or statement 2 equals true, or statement 1 equals true, and statement 2 equals true. Var 0, 1 multiplied equals 9. Var 0 is greater than 0, and var 1 is greater than 0. Var 0 equals 1, and var 1 equals 9. Unknown A, var 0 equals 9, and var 1 equals 1, unknown A. So these are true, but and it seems like unknown A could be defining possibilities. Why isn't that true? Okay. Okay, wait, or var 0 equals 3. And var 1 equals 3. Unknown A. No. Okay. Where are we putting the unknown A? So we're saying var 0 equals var 1 equals 1 and var 1 equals 9, unknown A. Var 0 equals 9 and var 1 equals 1, unknown A. So do I have to do the transitive, the equivalent where I say both sides? Because they're saying statement 0 equals true. Therefore, statement 1 equals true, statement 2 equals true, or statement 1 equals true, and statement 2 equals true. It could be that we need both. Feels like we would want a separator, but I guess unknown A is our separator. No signal change. Okay. Then perhaps you have a formatting suggestion. Dr. Batista, there's quite a bit of logic here. Your assistance will be appreciated by all. I see or, which is a logical or. Since statement 0 is true, either statement 1 is true, or statement 2 is true. Or both, right? If both statements are true, the or operation would say they're true, yes. Yes. So they're presenting different possibilities. Thank you, Dr. Batista. Okay, but I am also doing that and it doesn't like it. Okay, so statement 2 equals true possibility, statement 1 equals true, and statement 2 equals true possibility. And then we have var 0 equals 1 and var 1 equals 9 possibility, var 0 equals 9 and var 1 equals 1 possibility. And then we have var 0 equals 3 and var 1 equals 3. Possibility. Possibility. Clearly spelling is different. Posibility. Yes. So what's different here? Let's change our equals formatting a little bit just to be more conducive here. So we assume that they're both greater than 0. Therefore, var 0 equals 1 and var 1 equals 9 possibility. Var 0 equals 9 and var 1 equals 1 possibility. And what else does it want? Because we could do any number of things if we're allowed to do non-integers. I guess we could do ... to indicate any number of things. Well, I'm confused. Because if they're looking for the roots, this feels like all the roots. And didn't like the way that I laid them out. You know, it's possible that with them being the same, that doesn't need to be communicated twice. But this is how I had it before, and it didn't work. Right. How did this statement end? Statement 1 equals true and statement 2 equals true. So it used possibility ahead, whereas this used possibility behind. So maybe we should actually be just sticking it on like this. Okay, don't understand the syntax of this that much, but okay. 180,000 years. We'll never meet them. It'd be too far away. We'd be dead before getting there. They are probably dead now. The individuals who made this message, likely. The species as a whole, hopefully not. I hope not. It would have been nice to meet them. That is pretty crushing. Okay. Var 0 multiplied equals 4. Possibility count equals 2. Yes, because it's 1 and 4 or 2 and 2. Actually, no, it's What is the second possibility? Because oh, it could be 2 or -2. Var 0 equals 2 possibility -2. Uh, maybe we can say alternatively. Okay, var 1 multiplied equals 16. Alternatively, alternative, we'll just say alternative. For presenting multiple possibilities, the transmission's right. A, alternative B, alternative C. This is potentially quite a powerful linguistic tool. That's true. We can use it to help understand synonyms very much more easily. So var 1 equals 4 alternative -4. Okay, var 0, var 1 add equals 5, and var 0 is greater than 0, and var 1 is greater than 0. Alternative count equals, so we can do 1 and 4, 2 and 3, and then 3 and 2, and 4 and 1. So that would be 4. Okay, so point 0, move some amount on the y-axis, set point 1 line with point 0 to point 1, distance equals 6. So point 1 equals interesting. So if that it's going to be equal to var 0 minus 6. But I don't know if that is what the best way to communicate that is. I guess we could say 6 var 0 alternative zero, and we don't have a value for var 0. No, we do not. Let's see what they make of this first. Right. Alternative 0 var 0 minus 6 add. No. There's too much to go off of here. And so I don't know how we can iterate that there is just too many options. I still think the answer should just be 0, 6. That makes sense, but they're proving a point with alternative. They're demonstrating how it's used. Is there a chance there are 2 solutions? I guess. If our 0 were positive 6 or negative 6, the total distance would still be 6. Then maybe that's what they're looking for. Negative? No, both. Oh, because we're moving this to, and that move is set 1. The set 0 stays where it is. So then we are looking for -6. Or 6. Okay, great job, makers. Okay, 0 equals something equals true, alternative false. Okay, no, 0 is our title, so we need statement equals true or alternative false? No? Okay. Something that is both valid, something is valid if it is both true or false. So we need to present a statement that can either equal true or false. That feels vague. Okay. Let's see. Don't know. Can we say 2 equals bar 0, something like this? No. Can we say it's not a statement? What else do we have that can be either true or false? Maybe something with a conditional not? I'm stumped on this one. True, alternative, false. That is it. What do you mean that is it? True, false, those are the options. The options for our transmission, huh? The way your brain works upsets me, Bautista. So, we can say true equals true or false? That doesn't make sense. How is this message different? The system only detects new transmissions. I guess the meteorite isn't sending anything to say congrats, they're just sending us a new string of signals. Yes, the computer sees something different, so what's different? Found it! First signal. It went from 0 to a 1. Huh. And I'm... Does this also accept? Yes. What are they doing? Oh, great. Now we have a 2 instead of a 1. Blah. And is false just as valid? Yes, it is. Odd. Very odd. Dr. Doppler, we have a breakthrough. Oh, please, tell me everything. 179,442. What's that? That's how many years it's been since the meteor was first sent. 180,000 years. My goodness. So we'll never meet them. What makes you say that? Well, sir, we'd be long dead before arriving, even if we left today. And that's even if we could maintain the meteor's speed for human flight travel. We won't approach the technology for another few decades at least. But humanity will be alive. We can still meet them. Maybe not us as individuals, but our spirits will live on. That's a sweet sentiment, Doppler. But we run into the issue from the other end. And that is, what if they're not alive anymore? What if they've all died out? They've embedded a computer in a meteor and sent it trillions of kilometers specifically to us. 180,000 years ago. And we're worried about their well-being. They're smart creatures. If there was any threat to their species, they'd figure it out. So they're just waiting for us, waiting for a response. If they're waiting for a response, then you know what they'll need to give us, right? A return address. They need to tell us where they live. Do it. Godspeed, team. Find out where they are. Fascinating stuff. All right. So that was episode 20. Alan's journal. Status awe. 180,000 years sure puts things in perspective. Though it's still hard for me to imagine. There are real beings billions of miles away, desperate to say hi. I'm proud to be part of the team that makes this translation possible. Batista's log. We are very far away from the aliens. Very. Carrie's diary. Dear diary, more than ever I suspect each of us is understanding the gravity of the situation. Aliens are real and speaking with us. Doppler's report. We should expect a return address for the aliens' home planet, huh? I love meeting with the translation team. I couldn't believe how far that was at first. I wonder if they targeted us specifically, or if they sent a lot of meteors out. All right. Well, that is going to be the end of the episode. As always, if you enjoyed, don't forget to like and subscribe, and I will see you in the next one.